Venus is on fire. Right now, at this exact moment, the surface of our nearest planetary neighbor is cracking open. Lava is flowing across plains the size of continents. Mountains are erupting, and in April 2026, NASA released data that confirmed what scientists had suspected for decades but could never prove. This is not a theory. This is not a computer simulation. This is active, confirmed geological violence happening on a world that sits just 40 million miles away at its closest point, and nobody told you about it. Before this discovery, the scientific consensus was straightforward. Venus went through a catastrophic resurfacing event somewhere between 300 million and 500 million years ago. After that, the planet essentially froze geologically. The surface hardened, the activity stopped. End of story. The VERITAS mission changed everything. VERITAS stands for Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy.
What matters is what its instruments detected when scientists began analyzing the radar data in early 2026. Thermal signatures, surface deformation,
Fresh lava flows stretching across a region called Idan Mons, a volcanic formation nearly 200 kilometers wide, sitting in the southern hemisphere of Venus. The lava was not ancient. The deformation was not historical. The heat signatures were not residual. What VERITAS found was a volcano that had erupted within the last few years, possibly within months of observation. Let that land for a moment. A planet in our own solar system, a planet visible to the naked eye from Earth on clear nights, has been actively erupting, and science only just confirmed it in 2026. The reason this took so long comes down to one brutal fact about Venus. Getting close to it is nearly impossible. The atmosphere is a crushing wall of carbon dioxide laced with clouds of sulfuric acid. Surface pressure sits at 90 times what exists at sea level on Earth. Surface temperature reaches 465 degrees Celsius, hot enough to melt lead, hot enough to destroy any probe within minutes of landing. No probe has landed on Venus since 1985. For over 40 years, the surface of Venus has been observed only from orbit and from Earth-based radar. And radar, while extraordinary, has limits when trying to detect the difference between ancient lava and fresh lava across millions of miles of space. What broke the problem open was a technique called interferometric synthetic aperture radar, a method that compares surface images taken at different times to measure tiny changes in elevation and ground deformation. When scientists applied this to Venus data collected across multiple observation windows, they found something that should not have been there. The ground at Idan Mons had moved, not by millimeters, by significant geological amounts. And the thermal emission data showed a heat profile that matched active lava flows, not cooled ancient rock. The paper published in April 2026 did not use cautious language. The authors wrote that the evidence was consistent with ongoing volcanic activity. Multiple independent research teams reviewed the data. No one challenged the conclusion. Venus is alive. Now here is where this discovery becomes genuinely strange. Venus and Earth are often called twin planets. Same size, similar mass, similar distance from the Sun during formation. Scientists have long believed both planets started from the same basic composition of rock and metal, roughly 4.5 billion years ago. Earth is volcanically active. Venus is now confirmed volcanically active. The twins share the same geological heartbeat. But the surfaces could not be more different. Earth has plate tectonics, the slow, grinding movement of crustal sections that recycles material, drives mountain formation, and regulates the carbon cycle that keeps the planet habitable. Venus has no confirmed plate tectonics. Its surface appears to be a single rigid shell with volcanic hotspots punching through from below, like a pressure cooker with no release valve. Scientists now believe this is exactly what is happening at Idan Mons and at several other volcanic regions scattered across the Venusian surface. The heat from the planet's interior has no systematic way to escape, so it builds and builds,
and eventually tears through the crust in violent eruptions that reshape entire regions. The scale of what has been happening on Venus over millions of years is difficult to process. The lava plains covering most of the planet's surface were not laid down in one event. Radar mapping reveals layer upon layer of volcanic deposits, each representing eruption episodes that would have dwarfed anything in recorded geological history on Earth. The largest volcanic structure on Venus is called Mont Mons. It rises 8 kilometers above the surrounding plains. Mauna Loa in Hawaii, the largest volcano on Earth measured from its ocean floor base, rises about 9 kilometers. Mont Mons is the same scale, sitting in the middle of a planet-wide volcanic landscape with no ocean to hide its true size. And Mont Mons shows thermal anomalies in the 2026 data. Not confirmed eruption, not yet, but signatures consistent with elevated subsurface temperatures and possible ground deformation around the summit. Idun Mons is confirmed. Mont Mons is suspected. Researchers have identified at least 37 additional volcanic regions across Venus that now warrant re-examination using the same interferometric techniques that caught Idun Mons in the act. The picture forming is not of a planet with 1 or 2 active spots. The picture forming is of a planet whose entire geological system is in a state of ongoing violent activity, and scientists are only beginning to map the true extent of it. This raises an uncomfortable question that the 2026 paper does not directly address, but that planetary scientists are now discussing openly. Could Venus have once been habitable? The Standard Model says no. Venus today is a hellscape with no liquid water, crushing pressure, and temperatures that destroy complex chemistry. But models of Venus's ancient climate, running simulations backward through billions of years, suggest the planet may have had liquid oceans for up to 2 billion years before something triggered a catastrophic greenhouse runaway that turned it into the furnace it is today. 2 billion years is an extraordinarily long time. Life on Earth emerged within the first billion years of the planet's existence. If Venus had stable oceans for twice that long, the numbers become deeply uncomfortable. What ended it? The leading theory points to a dramatic increase in volcanic activity somewhere between 700 million and 1 billion years ago. A period of extreme eruptions, so intense that they flooded the atmosphere with carbon dioxide, triggering a runaway greenhouse effect that boiled away the oceans and left behind the crushing atmospheric hell that exists today. If that theory is correct, and the 2026 volcanic confirmation makes it more credible, not less, then Venus did not always look like this. Whatever existed in those ancient oceans before the catastrophe is now buried under kilometers of solidified lava and pressure no probe has ever survived long enough to sample. The 2026 discovery does not just tell scientists about Venus, it tells scientists about Earth. Because if Venus and Earth truly are twins, same formation, same composition, same basic geological activity, then the catastrophe that transformed Venus is a scenario planetary scientists now have to include in long-term models of Earth's geological future. Not on any timescale relevant to civilization as it exists today, but on geological timescales of hundreds of millions of years, the question of whether Earth could experience a runaway volcanic greenhouse event similar to whatever transformed Venus is no longer purely theoretical. It happened to our twin. The evidence is in the radar data. The lava flows are fresh. 3 missions are currently in development targeting Venus in the 2030s. VERITAS, if funding is restored, the European Space Agency's Envision orbiter, and India's Shukrayan probe. Each carries instruments designed to push past the limits of what current orbital data can reveal. The next decade of Venus research is now arguably the most urgent planetary science program in the solar system. Not Mars, not the outer planets. Venus, the planet visible from Earth every night for millennia, quietly hiding the fact that its surface is tearing itself apart. Of all the planets in the solar system, Venus was considered the most understood as recently as 2020. Close, well observed.
no great surprises left. That was the scientific consensus. In 2026, a dataset reanalysis confirmed active volcanic eruptions on Venus for the first time in history, something hiding in plain sight for 40 years of orbital observation, finally seen because the right technique was applied to data that already existed. Which raises the question worth sitting with. What else is hiding in plain sight right now, in data scientists already have, waiting for the right set of eyes to finally see it? Drop a comment below with which planet you think is hiding the next major discovery. The answer might already be sitting in a dataset somewhere, waiting.